guys? George over here, back again over at the Ratchet Report. For those of you who didn't watch my last video, it's actually my first video. We talked about catalytic converters, how they worked, and how a P0420 trouble code on a car might indicate a bad catalytic converter. Definitely recommend watching that, taking a look, and let me know your thoughts as well on these videos I make, and any input you can give is really helpful. So today we're going to talk about something very different. We're going to be talking about MAF, mass air flow sensors, and MAP, manifold air pressure sensors. And before I go into what these sensors are and what they do exactly, let's talk a little bit about the theory. So looking at any engine, whether it be an automotive engine, a boat engine, a lawnmower engine, they all need 5 things to run. They need fuel, they need air, they need spark, they need compression, and all these things have to happen at the proper time, so timing is also a factor. So since we're talking about air, specifically sensors that control airflow to the engine, MAF and MAP sensors, we also need to talk about fuel, since there's a delicate relationship between fuel and air, and I like to call this a car's air-to-fuel ratio. In shorthand terms, the AFR. So most cars at ideal operating conditions have an air-to-fuel ratio of about 14.7 to 1. And that's going to be 14.7 parts air to 1 part fuel. And looking at those 2 sensors I was just talking about, they're really critical because they factor into the air part of the equation. They tell the car how much air is coming in, and from that knowledge, the engine computer is able to determine the correct fuel and to get the correct fuel to air ratio based off the input of those 2 sensors I was just talking about. So how does it do this exactly? Well, looking at these sensors into a little more depth, there are 2 words that come to mind: expected versus actual. So any car is going to have an expected table of MAF or MAP sensor values, and I like to call this the MAP table. So this table is basically going to show load, engine load, versus RPM at any given point in time. And through experimentation and testing at the research and design facility for the automotive manufacturer, they're basically going to come up with a table of values that are going to tell them the expected values the computer should see at laboratory settings for any given RPM and load combination that the engine sees. So this covers the expected part. What about the actual? So when the car is running, it's obviously not going to see laboratory conditions all the time. It's going to see a table that is different from this table right here. But the value should be pretty close, right? Thinking about how the car runs in a laboratory at different temperatures should be pretty close to how the car runs in the real world at different temperatures. So there are going to be slight differences in these values, and they're not going to match. But there's a window in which these values are supposed to be pretty close to each other, right? And if it falls outside of that window and expected does not equal actual, then the car will throw a check engine light for either the MAP or the MAF sensor. So let's talk a little bit about how these sensors work, and then we'll kind of dive into the engine diagram I drew earlier and show how these sensors work in conjunction with the engine and all other components to produce a correct sensor signal. So let's look at an MAF, mass airflow sensor first. So before I was talking about expected versus actual. What is the computer seeing? What is the actual value versus what is the computer expecting to see, i.e., what did the engineers determine were the expected values during testing inside the research and development facility? So what it does is, here's our sensor, and basically the sensor is going to be housed on the intake side of the engine. So that's where air is coming in, air intake. This is our engine right here. And then we have air coming out of the engine. That's going to be our air exhaust. So looking at the air coming in, the job of the mass airflow sensor is to monitor the flow of the air coming into the engine. So that's generally going to be somewhere on your intake tube. So if we have our air intake, and I'll go ahead and draw this out in a little more detail. We actually have our intake manifold. I'm going to call that IM. And the MAF sensor is generally going to be just before this intake manifold. And let's look at how the MAF works in a little bit more depth. So I'll go here. The MAF actually has a device called a resistor in it. So I'll go ahead and kind of draw the inner workings of it. So if we have air going this way, this is going to be our air. There's a little resistor coming down from the top of the sensor. And this resistor is going to be maintained at a very precise temperature. And that temperature is going to vary depending on what automotive manufacturer you're dealing with. But the goal is, the theory behind this is if you run air over this resistor, depending on the temperature of the air, the computer is going to have to output a different amount of current going to the resistor in order to keep that resistor at the constant temperature it specifies. So let's say I'm putting in colder air. The car's computer is now going to have to input more current to the resistor to keep it at the same temperature. And this is basically what determines your airflow. So I'll go ahead and draw this. So there's going to be current coming in on this wire. Current coming in and current going out. Now this actually generally works pretty well, but it does have a few disadvantages. So since the sensor is before the intake manifold, it basically is making the assumption that everything working from here forward is working properly. And that doesn't always happen, right? Sometimes you might have an issue here. Let's say you have a vacuum leak on the intake manifold. The MAF sensor isn't going to see that. And that's oftentimes why manufacturers combine a MAF sensor setup with a MAP sensor setup, kind of as a like a backup in order to make sure the car is running properly at all times in the event that there is a problem, like a vacuum leak on your intake manifold. So let's talk about our MAP sensor next. I'm going to go ahead and erase this and redraw it. So I'm going to draw the system again. So we have our intake tube, our air intake, our engine, and our air exhaust. I'll go and label these components. So instead of measuring airflow like a MAF sensor does, a MAF sensor actually measures air pressure. And this is generally going to be in the intake manifold. Here's my MAF sensor. Basically, the inside of the MAP sensor is going to look something like this. So if this is the bottom of my sensor right here, where it connects to the intake manifold, it's going to have a tube that actually goes up to a diaphragm. And this is kind of a device that looks sort of like a plunger. And based off the position of this diaphragm inside this housing, the MAP sensor is going to output something called a voltage to the car's computer that is going to tell it basically what the incoming air, the MAP sensor that is going to tell the car's computer how much pressure is in the intake manifold. So let's say this plunger is all the way at the bottom. Let's say it's here. My pressure is obviously going to be lower, so this would be lower pressure. Than if it were at the top, producing a state of higher pressure. And this is key because you really need both sensors, right? A MAP sensor is going to measure pressure, but in order to fine-tune airflow calculations, you really need a MAF sensor in conjunction with a MAP sensor to run the car properly. Because as cars age, they develop problems. So that's about it. I hope you guys learned a lot about MAP and MAF sensors today and how they work. Just a reminder, a MAF sensor is generally situated before the intake manifold, measures air flow, while a MAP sensor measures air pressure. I hope these two things were helpful. Feel free to leave your feedback in the comments. Really appreciate it. And until next time.